If I could please have everyone's attention for a few minutes. So the key to solving this puzzle is this list of possible configurations. So I'm going to draw on here where we want Carol to be afterwards. Right, so in the first case we wanted to move up. Here we wanted to turn. In this case we wanted to move and turn. Here we wanted to move, turn, move, turn, move. Here we wanted to move, turn, move. Okay, so those are the 5 possible cases. But unfortunately, we can't know right away which case we're in because Carol is so nearsighted. So we have to we'll have to move and then look around again. So first of all, I would like to move forward, but I can't in this situation. So let me deal with this situation first. So if wall in front, what do? I'm in this case here. Turn left. Okay. And now I want to be careful to put on the else, because if in this case I want to do turn left and I don't want to do anything else. So otherwise I'm left with one of these other cases. What do I do first? So in each of these now I have no wall in front, so what do? I move forward. That's the first thing I do. And now I need to look at my world. So I am here, or I'm here, or I'm here, or I'm here. So which case do I want to tackle next? It's usually a good idea to look at the easy cases first. In this case here, I'm done, right? So what distinguishes this case? There's a wall on the right. So if there's a wall on the right, then I'm done. And that makes sense because that was my job, to bring Carol to the next position where she has a wall on the right. So if I have a wall on the right, I'm done. And I could write that down. I could say if wall on the right, done, else. But actually, to keep my code a little more concisely, I'm just going to say if not wall on right. And then I'll keep going. Then it's implicit that if there is a wall on the right, I'm done. So if there's not a wall on the right, then I keep on going. And so that means I'm now done with this case, and I have these 3 cases to consider. So what do I do next? So I'm here, or here, or here. What's the next thing I do? There is no wall on the right. I turn right. So now I am here, or here, or here. And I move forward. Now I am here, or here, or here. Now what do?
You end it, right? Once it's on the beeper?
Yeah, so what do I do if I'm on the beeper?
Just if Carol's on the beeper, end else?
Then I just do nothing.
Or just
I just leave her on the beeper. What do I do in this case? In the third case here. I have a wall on my right. What do?
You move forward.
No, I'm done. I just leave her at the wall so that the next call to step carries on. The job of step is to bring her to the next safe position. There's a wall to the right. She's good. So if there's a wall to the right, I don't have to do anything. If there is a beeper that she's on, then I don't need to do anything. So in the case that neither of those is true, I have to do more work. So I have to say, if not on beeper, and Not Wallen, right? Then what do I do? That's this situation here. Right now I'm here, and I want to be here. Turn right and move forward. All right. So here I have the pseudocode, and so with the pseudocode, now one can go to town and try this out with that little sketch that I've had, where Carol was here. And then you can kind of simulate it, and you can see how she goes along here and how it's all going to work. And you can see kind of the shape of the pseudocode. And it's just a bunch of if-else statements that are indented so that you can see what depends on what. So why do we bother with the pseudocode? I know that students do not like to write down pseudocode. I can see it in your eye. So why do we bother with the pseudocode?
Easier to find mistakes.
It is actually, well, it may or may not be easier to find mistakes, but the reason we're doing is that the alternative is worse. And here's the alternative. The alternative is that you walk up to your development environment, you type in a bunch of half-assed stuff, it doesn't work, and then students do this. You all know someone who does it. And then students randomly change things here and change them there, watch how the behavior of the program changes, and hope, completely irrationally, and against all common sense, and hope that after doing sufficiently many changes, that their program will work. Now I do agree that life works like that. We are here on this planet because our genetic information has changed and changed again and changed again, and every time it didn't work out, some species didn't make it. But it took a long time. It took 1 billion years. You do not have 1 billion years to try out all possible combinations of this program. You have to approach it with something in your head where you have some idea what these different pieces do. And the only way that we know to get these ideas is to think through this thing first and to write up what it is that you're thinking. And look what I was doing here. I was drawing these little diagrams because I, an experienced software engineer, cannot keep in my mind these 5 different situations. I could not remember exactly how the darn thing was oriented. I had to write it down on a little sheet of paper. I cannot think about this thing in my head. It's too much information. And then when I write something like this, it's easy for me to make mistakes, and then I need to be able to fix them, and I have to have it written down in some draft way. So it really, being able to jot down the pseudocode and to think through the pseudocode is really, really important, so that the first thing that you commit to the computer actually has a chance of working. In a few years, you will be at the point where you no longer need this. I could probably solve this, maybe. No, I could not solve this problem directly by typing it in. I would at the very least have to draw this picture and draw these orientations. And if I do that, I might as well write down a few else's. It's a cheat code. So we're having these labs to beat into your head that the pseudocode is an essential step to solving a more complicated problem. As soon as the number of things that you have to keep in your mind goes beyond 1 or 2 simple cases, get out the sheet of paper, draw a picture, write down some pseudocode, and only when you're satisfied that you think that you actually understand the problem, then it's time to code. And so the other way around is when you find yourself with, you skipped this step, or you didn't listen to your teacher. Not that any of you would ever do this, but say you did. And now you find yourself, you write this code, you have that step function, and it looks suspiciously meager. You know that there are 5 cases, but somehow you only have 2 ifs. What do? And this is the hardest thing to do in your life. The hardest thing ever. No. Giving up is easy. Anyone can give up. You close down your laptop to do another lab on your own, And that'll be the last conference for the semester. On Thursday, I'll see you again.
Make sure